Hey, what's up, Chem peeps? Let's crank it up a notch. We're going to take a look at some Lewis structures that have more than one central atom. And before you start to panic, recognize that for these types of structures, you'll be given the skeletal structure. And generally, you're going to be working with elements that strictly follow the octet rule, plus hydrogen. So these Lewis structures can generally be pretty easily completed as long as you remember that carbon typically forms 4 bonds, nitrogen typically forms 3, oxygen typically forms 2, fluorine and hydrogen each typically form 1. And if you're nervous, let's do some practice. First one up, N2H2. As you look at the skeletal structure, I have 2 central nitrogen atoms. As I try to decide how these atoms are going to be bonded to one another, the first thing I'm going to do is connect the hydrogen to the nitrogen. Boom. I know that the hydrogens must be single bonded to the nitrogens. And I know that nitrogen typically forms 3 bonds, which means that the 2 nitrogen atoms must be double bonded together. That gives this nitrogen 1, 2, 3 bonds, and this nitrogen 1, 2, 3 bonds. Now, remember that nitrogen also strictly follows the octet rule, so they must each also have a lone pair of electrons. Boom! Our Lewis structure for N2H2 complete. Oh my goodness! Let's take a look at propanol, CH3CH2CH2OH. Once again, you're going to be given the general skeletal structure. My suggestion, always just connect those hydrogens to the atom in the skeletal structure that they're closest to, recognizing that they will only ever be singly bonded. Boom! Next, recognize that your carbons typically have 4 bonds. If this first carbon already has 3 single bonds to each of the hydrogens, that must mean that it's singly bonded to its neighboring carbon, which gives it an octet. And that means that this central carbon, single bonded to each hydrogen and single bonded to the carbon to its left, must also be single bonded to the carbon on its right. Oh, also an octet. As I look at this final carbon, it already has 3 bonds, so its only option is to single bond to the oxygen, completing its octet. Now, as you think about oxygen here, I'm not going to create any more bonds. Again, oxygen typically forms 2 bonds, and I can't create a double bond with hydrogen, and I can't, in this case, create a double bond with carbon, because the carbon already has an octet of electrons, and it strictly follows the octet rule. Which means then, in order for the oxygen to also follow the octet rule, it must have 2 lone pairs of electrons. Oh, propanol, Lewis structure, complete. Finally, that brings us to acetone, CH3COCH3. Again, if you're given the general skeletal structure for the molecule, first thing to do, connect those hydrogens. You know they're going to be singly bonded to whatever atom they're closest to. They will only ever have a single bond. 2 electrons. Then work your way from there. As I take a look at this first carbon, it must be single bonded to the carbon in the middle. Can't be double bonded because then it would have more than 8 electrons. Same thing for the carbon on the right. And then we get to this central carbon. How do you think it's bonded to the oxygen? If you guessed double bond, you would be correct. Recognize that in so doing, carbon now has 4 bonds, completes its octet. Oxygen has 2 bonds, and therefore the remaining electrons must be lone pair electrons to complete oxygen's octet. Big takeaway here. Don't stress if you are given molecules with more than one central atom. Generally speaking, you'll be given the skeletal structure to work from. And even if you're not, you can use the structural formula, use the order in which you're given the elements to help you decide on how those atoms are bonded to one another. And lastly, if you just remember that carbon typically forms 4 bonds, nitrogen typically forms 3, oxygen 2, fluorine and hydrogen typically form 1 each, and that they all, except hydrogen, strictly follow the octet rule, you're on your way to success. Done.